Hi, I'm Miss Hearn. Let's get started. In this video, we're going to solve an equation which contains a radical. The equation is b plus 4 times the square root of b equals 21. It's the square root that makes this a radical equation. When solving a radical equation with a square root in it, one method is to isolate the radical term, square both sides to get rid of the radical, and then solve the resulting equation. Method 2, this is the method we'll use. We're going to use U-Substitution. Before I get into the nuts and bolts of using U-Substitution, let me tell you why I think that U-Substitution will be helpful. U-Substitution is often used to rewrite equations that don't look like quadratic equations so that they do. Now, a quadratic equation is any equation that fits the pattern of ax squared plus bx plus c equals 0. Let's focus on this x and this x squared. We have a term with an x, and then we have a term where if we took the other term and squared it, we would get x squared. Keeping that in mind, let's look at our equation we were given. B plus 4 times the square root of b equals 21. I'm going to rewrite it in standard form. B plus 4 times the square root of b minus 21 equals 0. And now I'm going to compare these variables and what's happening with them, the b's, to the x's in the general form of a quadratic equation. If I were to take the square root of b and then square it, would I get b? The answer is yes, because when you square the square root, you're going to eliminate the radical. So you notice that the same relationship that we had between x and x squared exists between square root of b and b. One is the other squared. When that happens, we can take the one, in this case the square root of b, and we can give it the name u. So I'm going to say let u equal the square root of b. Then that would mean that if I squared u, I would get the square root of b squared, or b. I'm going to use these two equivalences and replace the variables b and square root of b in the original equation. So instead of writing b, I'm going to write what it's equal to, u squared. And instead of writing square root of b, I'm going to write what it's equal to, which is u. This equation is a lot friendlier to solve because it's a quadratic equation, and we know several methods for solving quadratic equations. I'm going to solve this one. I like this one better. And then, after I figure out what u is, I'll go back and figure out what b is. If I know one, I can figure out the other one. So here we go. U squared plus 4u minus 21. Do you think this one will factor? I think it will, because if we factor negative 21 into negative 3 times positive 7, those two factors will add up to 4. So let's factor this into u minus 3 times u plus 7, and that means that u has to be 3 or negative 7. Well, that's great, but I was asked to find b in the original equation. So now we're going to use the relationship between u and b. I know u is supposed to be equal to either 3 or negative 7. So using the fact that u is equal to the square root of b, let's let 3 equal the square root of b and see what b would have to be. Now we have a fairly simple radical equation. If the square root of b is 3, then b would have to be 3 squared, or 9. On the other hand, if u was equal to negative 7, then plugging into u equals the square root of b, we'd have negative 7 equals the square root of b. Now, it's not possible to take the square root of a real number and get negative 7. So that means that there is no b that would make this statement true. That's not going to work out. So once again, we come to the same conclusion, that the only solution is b equals 9. I hope you found this video helpful. If you did, please remember to like it. And if you have any questions, you can always leave them in the comments section below.